This is Euclid Book 9, proposition number 10. And it says, if as many numbers as we please, beginning from a unit, be in continued proportion, and the number after the unit will not be square, neither will any of the other be square except for the third from the unit, and all those which leave out 1. And if the number after the unit be not cube, neither will any other be cube except the fourth from the unit, and all others which leave as 2. Let there be as many numbers as we please, A, B, C, D, E, and F. Yep, it's the same drawing we used in the last video. Okay. Let there be as many numbers as we please, A, B, C, D, E, and F, beginning from a unit and in continued proportion. So in other words, we'll have 1 is to A as A is to B, as B is to C, and so on and so forth. And let A, the number after the unit, not be square. So we're now going to say that whatever number A is, it's not a square number. That's what we're saying. I say that neither will any other be square except for the third from the unit, and those which leave 1 out. For if possible, let C be square. So now we're going to say, hypothetically speaking, that C is a square. Okay. But B is also a square by Euclid Book 9, proposition number 8. Therefore, B and C have to one another a ratio which a square number has to a square number. And as B is to C, so as A is to B. Now we're going to say, as B is to C, so as A is to B. Okay. Therefore, A and B have to one another the ratio which a square number has to a square number, so that A and B are similar plane numbers, which is Euclid Book 8, proposition number 26. Actually, it's the converse of that. And B is a square, therefore A is also a square, which is contrary to the hypothesis. Because we said A was not a square, now we're saying that it is. Therefore, C is not a square. Similarly, we can prove that neither any other of the numbers square except the third from the unit and those which leave 1 out. Next, let A not be a cube. Okay. At this point, we're going to say that A isn't a cube. I say that neither will any other be cube except the fourth from the unit and those which leave out 2. For if possible, let D be a cube. Okay. Now C is also a cube, for it is fourth from the unit. Euclid Book 9, proposition 8. That's Euclid Book 9, proposition number 8. Therefore, B also has to C the ratio which a cube has to a cube. And C is a cube. Therefore, B is a cube. Euclid Book 8, proposition number 25. And since, as the unit is to A, so will A be to B. In other words, as 1 is to A, so as A is to B. And the unit measures A according to the units in it. Therefore, A also measures B according to the units in itself. Therefore, A, by multiplying itself, has made the cube number B. Okay? A times A makes B. But if a number by multiplying itself makes a cube number, it is also itself a cube. This is by Euclid Book 9, proposition number 6. Therefore, A is also a cube, which is contrary to the hypothesis. Therefore, D is not a cube. Similarly, we can prove that neither is any other of the numbers cube except the fourth from the unit and those which leave out 2. Okay. And that is the whole proof. If you want to interject numbers into any of this, you are more than welcome. I will tell you more in a future video. Stay tuned.